Summarizing quantitative data, we can also look at some other numerical summaries or things we can sort of calculate or pull out of a data set. So the next step might to be locate a more precise description of some of the characteristics used to interpret a histogram, such as the smallest and largest value in a data set. Now usually you would have software such as StatCrunch, or you could do this in something like Minitab. Sometimes in Excel if you're just sort of sorting and doing really basic descriptive statistics. And there's some commands here on how you could use StatCrunch, but basically it's going to produce output which gives you some summary information. And these would be provided on tests or quizzes, but you want to know where to look for the different values and what each thing means. So for now, let's focus on the summary from the histogram that we did with automobile weights. Remember, before we could only give you the range where the rectangle covered for the leftmost or smallest weight of an automobile and the rightmost or largest weight for an automobile. But here we can actually see from the actual data set that the smallest was the minimum of 2,750 pounds and the largest or the maximum was 6,000 pounds. You also can tell that there were 80 values in the data set. So the sample size, n, would be 80 in this case. Now, another thing we might want to do is say, okay, what is the most typical value that we would observe? Or where is the center of a data set? Well, this leads to really the two most common measures for center, which are called the mean and the median. And we're also going to mention something called the mode. Now the mean is represented as X bar, or sometimes you'll see it as a Y bar, or really some letter with a line over the top of it. And basically all this means is add up all the data values you have and then divide by that sample size, the number of data values you have. So this is what a lot of people in common language would call the average, but really in mathematics and statistics the term average can take on a broader meaning, or it's not as well defined. So instead of saying average, we're going to use the word mean. Now you can see from the output that the mean is actually 4,104.6875. And we could actually round that off maybe to the 10th digit and call that 401 or 4,104 and 7/10, and then that would be in pounds. So we might say that the mean weight for the 80 automobiles in this particular sample turned out to be 4,104.7 pounds. Now the median is another common measure of the middle of a data set. Now the way you obtain the median is you have to first put the data in order, and then you sort of split that in half. So you find either the value that's in the middle if you have an odd sample size, or you take the average or the arithmetic mean of the middle two values if n is even. So let me show you what that would look like in terms of our data in an Excel file. So what I did was I took the initial weights, okay, that were in column A, and then I ended up putting them in order. And then what you can see is that, so if you ignore line 1, it really begins on line 2, and the data set goes down to line 81. So 81 minus 1 would be the 80 data points. What we want to do is we want to find the middle. So what we've got to do is go back and find the 40th and 41st, which will actually be on lines 41 and 42 in this case. But now they're the same number in this case. So when I add them together and get 8,000 divided by 2, I get 4,000 back again. So I would say that the median is 4,000. If you had two different numbers, then you would get a number that may not be in the data set. Okay, but when n is even, you're going to take the middle two values in the list after you put it in order. You've got to remember to put the data in order first. Then take the middle two values and just find the mean of those middle two values. If n is odd, once you put the data set in order, you just find the middle number. So if you had 5 data points, really the third value, once you put it in order, is going to be the median, because you'd have 2 values below it and 2 values above it, or you'd have 3 values equal to or less than it and 3 values equal to and more than it. Okay, so let's go back to Word. So basically, the median is always going to have at least half of the values that are equal to that number and less than it, and at least half of the values have to be equal to that number and greater than it. Okay, so in this case, we would just say that the median weight for the 80 automobiles in this particular sample can be calculated to be 4,000 pounds. Now, another way that people sometimes will mention a typical value is just to look at the one that happens the most often. Now, the mode of a data set, if you look at the list, is going to be the value which occurs the most often. Okay, so I'm going to go back to Excel again. And this column D actually counts how many times each number occurred. So 2,750 occurred once. 3,125 occurred 7 times. So if you go down and look, there's an 8, there's a 12, but then down here there's a 14. And 14 actually turns out to be the most common. So there were 14 observations of 4,750. So we would actually say the mode is 4,750 pounds. Now, the 12 is also very common, so we might also mention that that was another very common observation. Okay, and we might call this bimodal. Bi just meaning two, sort of like a bicameral house, right? You have the Senate and the House of Representatives, and it's called a bicameral legislative body because there are two legislative assemblies. In a histogram, what you would see is you would see 2 spikes. So if you're looking at a histogram, a lot of times what you're doing when you're looking at the mode is you're looking at where the tallest bar or maybe tallest region of a couple of bars are located. Okay, so it would be the range of values contained in a rectangle where that rectangle is taller than the ones that are around it. Okay, so in this particular example, I've already said that the mode turned out to be 4,750 pounds. Now, we're not really going to use the mode very much in this class simply because it doesn't have a lot of real nice math properties that we deal with. So it's just something that sort of says, hey, here's a peak in a histogram, or here's where a tall rectangle would be in a histogram. So this is something that happened a whole lot in the sample. We're really going to focus on the mean and the median. So why are there 2 main ways? Why do we have both a mean and a median to measure what is typical or where the center of a data set would be located? Well, in a symmetric histogram or in symmetric data sets, the mean and the median are estimating the same thing. The mean turns out to be the preferred statistic because it has some nicer mathematical properties. Okay, and we haven't talked about measures of variation and stuff yet, but basically it's a better way to measure where the center is as long as your histogram is symmetric or symmetric and mound-shaped. Now, when you have histograms which are skewed to the right or to the left, or they're non-symmetric in nature, or possibly they have outliers, the mean can be greatly impacted by these features. So as a result, we use the median because it's not at least directly impacted, and you know that it always has at least half of the values equal to it or less than, and at least half of the values equal to it or greater than. Okay, so for non-symmetric histograms of data, if we ask for where is the center or what is a typical value, you want to use the median. Now, visually what we can do is we can look and see that the mean and the median can be thought of from more of a physical perspective. So you can define the mean as the location of a balancing point for data in a histogram. So if you had a histogram, so this looks at the number of earthquakes based on magnitude, and it's maybe a slight bit skewed, but it's almost symmetric. Okay, so in this case, if I cut all of these rectangles out of a block of wood, okay, and I just had sort of the part from the line here at the bottom, and then I cut all these peaks out and cut this out sort of like a new piece of art, right? This is math art here. And then I wanted to balance that image on the point of a nail, where would that balance point be? Okay. Well, it turns out to be, I think it was like 6.96 or something. So the balance point is where the mean of a distribution would be. If I moved it over here, then what would happen is this edge would have a lot more weight and it would fall down this way if you tried to balance it right here. Similarly, if you tried to balance it out here, the weight would be greater on this side and this end would fall down, so it wouldn't balance. So this is your balance point. Now, the median is not that physical balance point. Rather, the median sort of looks at area. So think about if you were to paint a figure in two colors. So let's say we start painting in purple and we go left to right until we've painted exactly half of all the area covered by the rectangles. Then we switch over to another color like yellow. Wherever that dividing point is, where we switch from painting purple to yellow, okay, so that we have half the area covered in purple, half the area covered in yellow, that is going to be the location of the median. Okay. Now in symmetric histograms, such as this one, that's roughly symmetric, the mean and the median are almost at the same location. And in that case, we would actually want to use the mean because it has the nicer math properties. However, when you have data which is heavily skewed one direction or the other, then you're going to see that the mean and median aren't measuring the same location. Both of these are very near 7, whereas in skewed data, they're going to be measuring different numbers. So let's look at another example. So if you consider the amount of time played by people who started college basketball games in Division I, okay, and these were men's Division I games between the seasons of 2008 and 9 to 2012-13, so 5 seasons worth of data. Take all the starters and measure how long they played. Okay, how many minutes did they have of game time? Well, the histogram below, okay, was made from that data, and you can see that it's heavily skewed to the left. As a result, the mean and the median are not going to be the same number. What happens is that the mean is pulled the direction of the skewness. So there's not a lot of people that played real short times, but the fact that there's some that are in the data set pull the mean this direction. Okay, so the mean turns out to be about 27.9 minutes, whereas the median turns out to be 29 minutes. So here we can see that the mean is going to be smaller than the median because the data is skewed to the left, as you can see in the histogram. Now, I haven't given you a way to really tell whether the difference in the two numbers, the mean and the median, is a sort of large value in terms of magnitude. The issue is sometimes you can just sort of, from knowledge, know. So if you're spending $150 per book on average for course textbooks, and then you find one for $50, you know that that $100 difference between 50 and 150 is a big amount of money. Whereas if you're talking about, you know, is $100 a large amount of money in terms of maybe annual salary? Well, if you have somebody who is making $50,000 a year versus they could take another job and make $50,100 a year, that $100 difference may not be significant. And what that just means is maybe they shouldn't switch jobs because they're going to have to start over, they're going to have to meet new people, get used to different people, new work environment. Maybe it's not worth the extra $100. Okay, so it really depends on scale. And once we get into variability, we'll mention how you can use one of the numbers in variability to talk about scale. And then if the mean and the median are more than, you know, 1.5 or 2 times that scale measure, then you're going to be able to say that they're significantly different. But right now we haven't talked about that. So this is just sort of a, sort of guess. Is 1.1 minutes a lot of time in a basketball game? And a lot of people would say that's not really significant. but it actually turns out that in this case it really would be. So this is just really an overview of when you have symmetric or non-symmetric data, and the measures mainly of the mean and the median, and when you use each one. So remember, you want to use the mean when data is symmetric, use the median when data is non-symmetric.